Okay, so in this one, we want to find the volume in the first octant of the solid form between the cylinder z equals 4 minus y squared and the plane x equals 1. I think we should draw a little bit of the space figure here. We may not have to draw everything. But to get an idea of what the solid region is, I think I need a little picture here. So, and then we always need to draw R, or almost always. Okay, so z equals 4 minus y squared. That would be what kind of curve is that in the, so if this is the y-axis and this is the z-axis and this is x, what kind of generating curve does z equals 4 minus y squared have? It's a parabola. So this is a parabolic cylinder. Let's draw the generating curve. So 4 minus z equals 4 minus y squared. So y is taking over the role of x, and z is taking over the role of y. My mom's calling. That'd be funny. If we had more time, I'd have you all talk to my mom. Why are you calling during class? And she'd be all, even though I've told her before, oh, you're teaching right now? Gosh, you're teaching late. That'd be the reaction. And I'd be all, I know. Tired. I feel like going to sleep. So what would the vertex of this thing be? True. Okay, so in just the YZ plane, it'd be 0 for Y and 4 for Z, right? Okay, and then if you plug in 2 for Y, somebody noted, you can get the y-intercept, right? So like that. And so it's going to keep going down like that, right? Oh, it does say for the first octant, so never mind. That's why I drew just the first octant. I thought I had a reason, and then I didn't see it for some reason. Okay, so just the first octant, so I will just be interested in that portion. And then you translate that generating curve parallel to the variable you don't see in the equation, right? The x-axis. And then how far out? Well, this gives you a wall, doesn't it? X equals 1 in space is a vertical plane at a position of x equals 1, no matter what these y and z coordinates are. So I don't need to draw that wall. All I need to do is go out. So obviously I'm not scaling this the same. I'm going to call that 1 on the x-axis just so you can see it. Obviously, I'm not using the same scale distance here. So translate this generating curve parallel out to that distance of 1 from the YZ plane. And so the only part of x equals 1 that I'm interested in is this wall that blocks it off, right? Okay, the floor of this solid is formed by part of the xy plane, that rectangle that you see. Does everybody see the rectangle here? The ceiling is kind of both a ceiling and a wall, right? So what gives the ceiling? It's this, yeah, there you go, that formula right there. So it's z equals 4 minus y squared. And then the back wall is formed by part of the YZ plane, the side wall by part of the XZ plane. Does everybody see that? All right, so let's see. So our integrand is going to be basically the ceiling, right? So 4 minus y squared. And then the differential order, does it really matter? dy dx. And then, so what's the region that we're integrating over? So does everybody see the rectangle? The scaling is a little distorted. It actually goes to 2 on the y-axis, right? And then 1 on the x. So if I get the scaling closer to accurate, although it's still not the same on both axes, we have this sort of rectangle, right? Oh, okay. So I don't think we need to draw a representative rectangle when we're integrating over a rectangle, right? So what does y run from? So this is our region R, right? So if you wanted to draw a representative rectangle, you could. Not a bad habit to develop. But the bottom and top are going to be given by the same values on the big rectangle for R. So what does y run from? 0 to 2. What does x run from? 0 to 1. And I'm gonna stop there with this one, because I bet you guys can evaluate that on your own. I bet the hard part is setting it up, right? Or you thought the hard part was setting up, but now you see it's not so bad.